Hello PLP geometry and welcome to the second lesson in Unit 7. So again, in Unit 7, we're kind of combining two units into one just to kind of get us everything taught before the state test. So we're doing 3D geometry, and we're doing probability. And we are definitely still in the 3D geometry world, okay? This is going to be a video 2A. Okay, and this is volume of prisms and cylinders. Prisms slash cylinders. So in the last video, we talked in general about the 3D figures we're going to focus on. So today we're going to focus on prisms, all right? So let's remind ourselves about prisms, and then we'll get into some problems, right? This is definitely the biggest of the volume lessons. So again, that's why it's in two videos. So to find the volume of a prism slash cylinder, and again, a cylinder is just a prism with a circular base. So to find the volume, okay, we need to remember two things. Number one, that we have two congruent bases, and number two, they're parallel, two congruent parallel bases. So again, if you need to write the words out, congruent parallel bases. So I'm going to do two examples here. The first one is going to be a triangular prism. So to make a triangular prism, I'm going to start with a triangle here and that same triangle in the back, right? So this is my front face, this is my back face. Again, these will be my bases, right? I will connect corresponding vertices. Boy, I try. That was bad. Sorry, dude. So that's supposed to be there. That's supposed to be there. And then this one I'm going to make dotted, right? So when we find the volume of a prism, the volume of a prism is the area of the base times the height of the prism. So in this picture, this triangular face, that is the base. We would need this base area. So capital B stands for base area. So whatever shape it is, use that area formula. And then the height, H, is the height in between the bases. So again, the two bases are on the front and the back, right? These are the two bases. So we would need this length, which is the height connecting them. That's the height. So we're talking about the height of the prism. And again, it is the height and it goes between your bases. But this is our formula, our generic formula. This is on the OST reference sheet. I will give that reference sheet to you once you begin your Unit 7. Okay. Now, the other shape we're going to talk about is a cylinder. So for a cylinder, our bases are circles. So I'll make a circular base here. I'll make a circular base here. Again, we'll connect those two to make like a pop can, right? If you want to be all the way correct, right, you would erase some of those to make that dash because you don't really see the bottom of that back, or the back of that bottom base, but there you go, okay? And again, the volume formula here is still going to be area of the base times the height, but we know that for a circular base, right, the area, so I'll call capital B, the area of the base is pi r squared. This is still my height going in between the circular bases. So for a cylinder, the volume formula is, in place of that capital B, we put pi r squared, and then the h is still the h. So these are the two formulas you'll need, and then you just have to know the common formulas for the area of a triangle, area of a rectangle, area of a square for the base shapes. Now, the last idea that the state likes to bring into geometry, which, again, they can if they want to, is density. So density to me is more of a science term. So when we talk about density, it is the mass of an object compared to its volume. The mass of an object compared to its volume. And this is why it is a concept we talk about in geometry, because it involves the volume, right? Now, again, in science class, physical science, you probably learned this formula: density, capital D, equals lowercase m mass over capital B volume. So density equals mass divided by volume. And when you have the units for density, right, they will be in a measurement of mass. So for instance, gram or grams per, and then your volume, typically it's something cubed, like cubic inches. So grams per cubic inch. And again, the label there would be G per inch cubed. So just be aware of seeing those type of labels. That means density. All right, so we're going to do 2 problems here and then stop the video and then 3 problems in the next one. Okay, so our first example, so example 1. Okay, so we have an aquarium. I'm trying to shorthand these examples as best I can. So I have an aquarium and it's a rectangular prism. So think of a box, right? Holding or holds 540 inches cubed of water. The width equals 6 inches. The height equals 5 inches. And we need to find the length. Find the length to the nearest tenth. So you have an aquarium. It's a rectangular prism, holds 540 inches cubed of water. Its width is 6 inches. Its height is 5 inches. Find the length to the nearest tenth. So if you want to draw a quick picture, it's not necessary. I'll just do it for you, right? So here is my rectangular prism. So I'll just do 2 rectangles, right? Connect them. So we know that it holds 540 inches cubed. That's our volume. So our volume is 540, right? I know that because it's inches cubed, okay? So again, on here, again, I'll call the width 6. I'll call the height 5. We need to find this length. You can call it X or L. I'll just call it L. That's a cursive L. That's a 5 back there. Sorry for not being too good. This is a 5. Okay, so we go to our generic formula for the volume of a prism. Volume equals area of the base times the height. Again, this base is a rectangle. We'll consider this as the base. And again, to find the area of a rectangle, it's just length times width. So our true volume formula is just going to be length times width times height. And again, from a young age, I think you were taught that to find volume of a box, you multiply the 3 dimensions. Now, what did they give us? Well, they gave us the volume was 540. That's going to go in place of the V. So we are not just plugging and chugging to find the volume. They gave us the volume, right? I call these backwards problems. The length, we don't know, so you can call that X or L. The width, they told us, was 6. And the height, they told us, was 5. So notice our unknown is the L. We're trying to get the L by itself. So the first thing I'll do is I'll simplify 6 times 5. So this is 540 equals, you can put the 6 times 5, what it comes out to be in front of the L. So 6 times 5 is 30, so that's 30L. And now to get L by itself, we need to divide both sides by 30. And when you do that, you get 18 equals L. So our answer here, our length would be 18 inches. And again, if you think of an aquarium, right, it's usually longer, right? The width is how deep it is, and the height is, again, that makes about sense. Perfect. Okay, next example for this video. Okay, so now let's move on to cylinder world. So example 2. So we have a cylindrical coffee cup. Cylindrical coffee cup. Okay, height. And again, I'm just doing shorthand. I'm cutting out a lot of the verbiage. Height is 8 centimeters. Volume equals 159 centimeters cubed. And they want us to find the diameter. Find diameter to nearest tenth. Okay, I'm going to change colors for this one. So again, you don't need to draw a picture, but if you want to, here's our picture, right? Here's our cylinder. So it holds 159 centimeters cubed. So that's our volume. So our volume is 159. So again, this is not a plug and chug. This is a work backwards question. Now the height is 8. That's going to be that vertical side going between the bases. And we need to find the diameter. Now, the diameter of a circle goes all the way across it. The radius just goes halfway across it. So the diameter is equal to 2 radii. That's going to be important for this problem. Okay. All right, so now we go to our generic formula. So area of the base times the height, but we talked about it earlier. The area of the base is a circle, so it's pi r squared. So our volume formula is pi r squared h. Now we know our volume is 159 equals pi is pi. R squared we're going to leave alone because we don't know the r, and then our height is h. So times h or parenthesis h, whatever you want to do. Okay, so again, we need to solve this for r. So the first thing we're going to do is we're going to simplify the pi and the 8. Now this is going to be an ugly number because you can use the pi button. So 159 equals, I'll put it in front. So let's see what I can do in the calculator. So again, it's going to be an ugly number. So we go 8 pi. So we get something like 25.1327 ... Again, don't round that. That's r squared. So we multiply out the 8 and the pi. So now we're going to take both sides, and we still need to get the r squared by itself. That number is multiplying with the r squared. So we're going to divide by that decimal number. And again, do not round too early or you'll be wrong when you do the problem. Right? So again, you can just copy and paste it out of Desmos, Ohio. So we're going to take 159 and divide it by that number. And again, don't round this. So we get 6.3264, blah, blah, blah. That equals r squared. And now we just have to remember that to get rid of this squared, we must take the square root of both sides. And now we're going to type that into Desmos. Again, try not to round. So the square root of that answer. And we get an r value, and I will not round yet, 2.5152. Now, we need the diameter. The diameter is 2 radii. So to find the diameter, we're just going to take that number and times it by 2. 2 times 2.5152, blah, blah. So in my calculator, I just do times 2 of that number. And now I get my diameter is 5.03. It wants me to round to the nearest tenth. That is the 0. Where the 0 is, the 3 does not change the 0 to a 1. So my diameter is 5.0, and that would be in centimeters. Okay. All right, so that's the end of the first video. Video 2B is coming up next.